let's dispel some myths and make a really cool science experiment using candles and water. This is a good one on atmospheric pressure and the chemical reactions. Let's go! Welcome to Destructive Creativity. We exist for you, for science, and for fun, so if any of those things appeal to you, make sure you subscribe. Okay, so I have a petri dish here full of green water and one little candle. I'm going to show you the experiment right now, and then we'll explain what's going on later. I'm going to light the candle, and then I'm going to cover it up with another glass. Don't want to spill the water. There we go. Now that candle is going to burn in there until all of the oxygen is used up. And as you can see, right now, nothing is happening. The water level is staying about the same. But wait until it's used up all the oxygen, and then we'll see. So it just burnt out, and now look at that, there it goes. The water level is creeping up the sides of the container inside of that petri dish. So why is this doing what it's doing? So this one fascinates me because there is a lot of answers on the internet and YouTube that are factually incorrect. So let's debunk a few of those wrong answers. So one of the more popular ones is the fact that hot air takes up more volume than cold air. So as that candle is heating up the air around it, it's actually forcing air outside of the jar down through the water, bubbles up through the edges, and then as it cools, then the hot air contracts and creates a vacuum inside this little container, and then that is what causes the atmospheric pressure to push on the water and then push the water up through the jar. So yes, that has elements of the truth, but we can observe that no air is escaping anywhere around this jar. So that can't be the answer, even though a lot of places say that that is. Number two, one that I saw was quite popular was the fact that when the candle is burning up the oxygen, it's releasing carbon dioxide, and carbon dioxide is being absorbed by the water, therefore creating a vacuum and an imbalance, etc., etc. Well, again, that has a tiny, minuscule amount of an effect, but that has not nearly this much of an effect. So what's actually happening here? Well, it's a combination of both chemical and physical properties. The chemical aspect is when that candle burns, it's using up twice as much oxygen as carbon dioxide, as it is producing carbon dioxide. And that is what creates the imbalance. That creates the volume shift, as it were. If that's what's happening, why isn't the water level rising consistently? Because we saw that the water level only rises at the very end after the candle has gone out. Well, that's where the physical aspect comes into play. As the oxygen is being depleted and carbon dioxide replacing it with smaller volume, the air around it is also warming up and increasing volume. So the air is increasing volume while there's simultaneously becoming less air to heat up. The end result is it stays roughly the same until the candle goes out, it uses up all the oxygen, and then the air starts to cool inside of this jar. And then it's at that point that we see the water level begin to rise because the atmospheric pressure is pushing on the water, which is then driving the water inside of the jar and it rises up. We can say consistently that the water level inside this jar will raise approximately 1/10 of the volume of this jar every single time. So cool! Do you have a favorite science experiment? Share it down in the comments. I would love to hear it, and I would love to do it, honestly. This is Destructive Creativity. If you enjoyed this, hit that subscribe button. We have new stuff coming out every single week. See you next time. Bye!